The periodic table was first created by a scientist by the name of Dmitry Mendeleev in 1869. And what he did was he cataloged the then 60 known elements according to their properties, which repeated themselves. However, nowadays the periodic table is arranged according to atomic number, so how many protons each element has, rather than the atomic mass, which is how Mendeleev first organized his periodic table. Now, in the organization of the periodic table, the elements are arranged according to 4 basic patterns. So, as I stated previously, one of the basic patterns is atomic number. The periodic table is also organized to separate metallic and non-metallic elements and their properties. It's organized according to group number, where there are 18 groups in total. So remember that groups are the columns in the periodic table. Okay, so this right here would count as one group. Okay, this would count as the second group, so on and so forth. The periodic table is also organized into rows, which are called periods, and in total there are 7 periods. So just as a reminder, the groups, those are the vertical columns. And the periods are the horizontal rows. Now, there are specific names for certain periodic table groups that you should be aware of. Okay. The first one is going to be the alkali metals, which is group 1. So these are soft, shiny, silver in color, and highly reactive, and they're on the far left-hand side of the table. So if we take a look at our table here, group 1, that's going to be this group here. Okay. However, please remember that hydrogen, while it is placed in group 1 because it acts similar to the other elements in group 1, it is a nonmetal and as such does belong over here. However, it doesn't necessarily always act like the elements in group 17. So the alkaline earth metals are group 2. They are shiny and silver as well, but not as soft or reactive as group 1. So examples of elements in group 2 are going to be beryllium, magnesium, calcium, strontium, barium, radium. Okay. For the halogens, those are going to be in group 17. Those are poisonous and react with alkali metals to form salts. So group 17 are halogens. That's going to be right here. Okay, so it includes fluorine, chlorine, bromine, iodine, and astatine. For our noble gases, that's going to be group 18, and they are incredibly stable because they have that full valence shell. So that's why they don't want to react. So group 18, or our noble gases, which are sometimes called inert gases, okay, that's going to include helium, neon, argon, krypton, so on and so forth. So each vertical column on the periodic table, as we've discussed, is called a group or a family. You can use either term, and there are 18 groups. Each horizontal row on the periodic table is called a period, and there's going to be 7 periods. So elements in each group or period share similar chemical and physical properties. So we're given a periodic table in our notes here, and we're just going to go ahead and name all of the groups here. Okay, so most of them were mentioned on the previous page. So starting on the far left with group 1, those are called our alkali metals. Group 2, those are called our alkaline earth metals. Okay. From group 3 to 12, those are going to be called our transition metals. So those are going to include from here to here. Okay, and as you can see in the bottom here, these 2 rows, these are part of period 6 and 7, so they actually fit into these rows. That is part of the main periodic table. There's just not enough room to put them in this diagram there. Okay, so that's why they kind of have them as an excerpt going out. So all of these belong to the transition metals. Okay. Now, group 13, 14, 15, and 16, they don't really have a name, so that's why we're skipping over them. Group 17, as we said before, those are our halogens. And group 18, those are called our noble gases, or sometimes people call them inert gases. So, as we've said before, the periodic table is split up using this dark blue staircase line. It splits up the metals, which are on the left of the staircase line, and the nonmetals, which are on the right-hand side of the staircase line. Okay, so metals are more reactive as you move down a group, so going this way, and nonmetals are less reactive as you move down a group. Okay, so for metals, as you move down, they get more reactive. However, for nonmetals, as you move down, they get less reactive. Okay. Reactive properties gradually change from left to right along the periods. Okay, so if we're talking about the metals, they get more reactive as you go down. Okay. And they also get more reactive as you move to the left of a period. Meanwhile, for nonmetals, we're going to have an opposite trend. Okay, so it said it a little bit differently down here than how I'm going to say it, but I'm trying to represent the same idea. Okay, so the note said, okay, nonmetals get less reactive as you move down. Okay, but what we could also say, that's a true statement, that aligns a little bit more with, how it gets more reactive, is for nonmetals, as we move up the group, you are going to get more reactive nonmetals. And also, as you move to the right for specifically nonmetals, they get reactive, or more reactive, sorry. Okay, so if we're looking at the nonmetals in period 2, out of all of these, fluorine is going to be the most reactive. Okay. Similarly, if we look at group 17, so this column here, it should include all of them there, but as you move up the group, the nonmetals get more reactive. Okay, so once again, fluorine is the most reactive nonmetal in group 17. Now, elements to the left of the staircase of the periodic table are metals, and elements on the right are nonmetals, which are located on the right of the staircase line. Elements, except for aluminum, bordering the staircase, those are called metalloids. Okay, so these purple elements here, so let's circle them. With the exception of aluminum, all those purple elements, those are called metalloids. So let's do some highlighting because this is some pretty important information here. Right, and then let's also highlight this. So some characteristics of metals are, most of them are silver or gray in color. Most of them are shiny, excellent conductors of heat and electricity. A lot of them are bendable, or you can stretch them a little bit, and they're going to be solid at room temperature, the exception being mercury. And all metals are going to be able to form cations. So as a reminder, cations, those are the positive ions. Now, how you can remember that is cations, the word has a T in it, which looks like a positive sign. So that's how you can remember cations are the positive ions. Now, characteristics of metalloids, they're going to have some properties of metals as well as nonmetals. So if we look back at our periodic table, the metalloids that are to the left of the staircase, so like germanium, polonium, antimony, those metalloids are going to have slightly more metallic properties, but they do still have some non-metallic properties. Whereas the metalloids that are to the right of the staircase, they're going to have slightly more non-metallic properties, but they still do have some metallic properties. Okay. Now, nonmetals, those are poor conductors, but there's lots of different colors for nonmetals. They're dull, solids are going to be brittle, and they can occur at any different state. So they could be solid, they could be liquid or gas, whereas metals, those are mostly going to be solid. Okay, but nonmetals, those are going to form anions. So anions, those are the negative ions. So once upon a time, one of my students said that anions, the word kind of sounds like onions to her, and she always thought about cutting onions, and that made her cry just because of all of the onion aroma there. And so that's how that student remembered that anions are the negative ions, because onions made her cry. Okay. For compounds, there's two main types of compounds that we're going to be looking at: ionic compounds and molecular compounds. Now, those aren't the only types of compounds that we deal with. However, those are going to be the main two. So, ionic compounds are going to consist of a metal and a nonmetal. Okay. So in order to be able to identify an ionic compound, you got to know where you can find your metallic elements and your nonmetallic elements. Now, ionic compounds, they form ionic bonds. Okay, so ionic bonds get formed when electrons get completely transferred from the metal to the nonmetal. So some properties of ionic compounds: they're going to be solid at room temperature, and they can conduct electricity when they're in the liquid state or aqueous state. So an example of an ionic compound would be sodium chloride, or if we wanted to write the chemical formula for that, that would be NaCl. For molecular compounds, those are formed from two nonmetals. And in molecular compounds, we're going to have covalent bonding, which is when electrons are shared. Some properties of molecular compounds is they can be at any state, so solid, liquid, or gas, at room temperature, and they do not conduct electricity in liquid or aqueous form. An example of a molecular compound would be sulfur dioxide, or SO2. Okay, so sulfur as well as oxygen, those are both nonmetals. That's why that's a molecular compound. Now, within molecular compounds, and specifically talking about covalent bonding, there's actually two types of covalent bonds. There's going to be covalent bonds where electrons are shared equally and not equally. Okay, so we'll get into that in future lessons, but just as a heads up, that's what we're going to be covering. Some other types of compounds would be metallic compounds. So that's when you have a compound that's only made out of metals. Okay, so for example, if we had copper and zinc bonded together, that would be an alloy, because there's two different metals there, or in other words, it would be a metallic compound. Other molecules that you need to be aware of are elemental molecules. Okay. And you know what? Let's go back and let's highlight ionic compounds and molecular compounds, because those are pretty important. Okay, so elemental molecules, they're just made of two or more of the same non-metal atom coming together. So there's two types. You have your diatomic elements, so that means whenever they're by themselves, there's always two of them. So our diatomic elements are hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Okay, so some people like to memorize that by either like the memory device or the mnemonic device, have no fear of ice cold beer. So each of these letters corresponds to the symbol of the element. Okay. Except for C. That's supposed to be referring to chlorine there, so it's not a perfect memory device there. But there's two other ways that you could help yourself remember what the diatomic elements are. So since there's 7 of them, what happens on the periodic table is our diatomic elements, with the exception of hydrogen, they form a 7. Okay. So you could use that to help you memorize, or my personal favorite for memorizing the diatomic elements is just saying Hofbrinkel. So that's just rearranging the symbols for each diatomic element just a little bit differently. So Hofbrinkel. Okay. But especially when we get to writing chemical equations, you absolutely must know what your diatomic elements are as well as your polyatomic elements. Now, there's not as many polyatomic elements, but what they are phosphorus. So whenever phosphorus is by itself, there's 4 atoms grouped together. Sulfur, so there's 8 atoms of sulfur grouped together whenever sulfur is by itself. And ozone, or O3.